Welcome Decode 2020. My name's Reyes, and I'm going to be covering a talk today called Asking the Right Business Question, the most important phase of the data science process. I'm a data scientist myself, and I've worked on many projects over the years, and what I've found is the most common source of failure when it comes to data science and analytics projects and machine learning projects is that they don't start with the right business question. So I'm going to talk a lot more about this topic in this talk. I am with you live in the chat box as well, even though this is a pre-recorded talk. But I am here with you live in the chat box, so please jump in with your questions. As I'm not delivering the talk while I'm live with you, this is a pre-recording, I will be able to get to all of your questions. So first up, let's start with some data. Okay, I am a data scientist. I like to start with the data. So 60% of big data projects fail to go beyond the pilot or experimentation phase. This is some research that came from Gartner in 2017. Gartner being obviously one of the top data and analytics research institutions. They do a lot of research into the data analytics industry worldwide. The author of this study is a gentleman named Nick Hudecker. And a few months after this number came out, this 60%, which was quite controversial in the industry, he put out a tweet where he said, "We were too conservative. The failure rate is closer to 85%. And the problem isn't technology." So what we have here is 85% of big data projects failing to go beyond the pilot or experimentation phase. And I know that in the projects I used to work on, in my role as head of data science at Altus Consulting, a consulting firm down in Australia, we were working with really great people there. And still, a lot of the time you would see these projects not go beyond the pilot or experimentation phase. They would fail for various reasons. Of course, you would have some very successful projects, but a lot of them would fail. And so we have to ask ourselves the question of why do these projects tend to fail more often than other sort of IT projects? And I'm going to cover a few reasons in this talk. One of the reasons, which I'll just get out of the way quickly, is that a lot of the people who work on AI or machine learning or data science projects have this obsession with what I would call cool techniques, and they don't focus enough on business value. So to break this down a little bit more, I've created this matrix here where on the left, we have how data science teams should select their projects. On the vertical y-axis, we have business value generated. Of course, we want to generate more business value, all other things being equal. And on the x-axis, we have the feasibility of the project. And of course, we prefer projects that are highly feasible, meaning we can pull them off. And so when we are kind of sitting there deciding what project we should do, I recommend writing down on paper the universe of projects that we could pursue. So maybe there's a natural language processing project that we could pursue, which we use to assess the sentiment of our customers. Maybe there's a machine learning model we could build in order to better classify spam emails or to identify malware. Maybe there is a major project where we could partner up with perhaps even with a competitor and share data so that our models have more data to learn from, so that our antivirus software detects better because we share data to have bigger training data sets, for example, right? So there's all these projects that we could pursue, and each one generates a certain amount of value, which can be often hard to estimate in advance. and each one has its own level of feasibility. Now, where I like to start is with the quick win projects. These are the projects that are highly feasible, and despite being really easy or relatively easy, they generate huge amounts of value. So we do these first. Over in the top left, we have our major projects. So I mentioned earlier, maybe one project might be sharing data with one competitor. That might allow us to have larger training data sets in order to train our models, meaning our software might be better than the other, 50 competitors in the market. These sort of projects are low in feasibility because, you've got to get lawyers involved, and, there's risks and things like this to, teaming up with a competitor, but they may generate high amounts of value, for example. Okay, and then in the bottom right, we have high feasibility projects that are easy to do, but they just don't generate that much value, right? And so we do those if the top ones, the top right and top left, are done. And of course, if a project has low feasibility and low value, well, we don't want to do projects that are difficult to pull off and don't give us much value in the end. Okay, so this is a great framework for selecting projects, and I recommend actually drawing these axes and listing your potential projects on the two axes. Now, unfortunately, how I've seen a lot of data science and machine learning teams, I don't see this in our US clients so much. I don't see, well, I have actually seen it there, but I don't see this in mature companies. Mature companies in terms of machine learning and AI, I don't see this much. But in companies that are early on in their journey, on their machine learning, AI, and data science journey, what I see is projects being selected using this framework. And so, and this is kind of a bit of a joke that I've put together here. You're a real geek when you joke using graphs, but what I've got here, there's an element of truth to this. And what I've literally seen in some teams is that the data science teams gravitate to those projects that allow them to use cool methods. So on the y-axis, I now have, will I get to use a cool data science method? Such as, I don't know, neural nets, convolutional neural nets, or, support vector machines or something like that. And then on the x-axis, will I get to use a cool tool like Keras or TensorFlow or Azure ML Studio or something like that? And so I find that a lot of data science teams gravitate away from certain projects because they don't get to play with the tools or methods that they want to play with. And that's terrible, right? Because we shouldn't be choosing projects based on the tools or methods. We should be choosing them based on business value and feasibility. And then the question is, well, why do data scientists do this? Why don't they focus on business value? And it's because if you look at the syllabus of any master in data science program or undergrad in data science program, the topics look like this, right? Like, I can't see any topic here or here that's, says, focuses on how to select projects in the real world, or how to focus on business value. And so it's almost like you can't blame them, right? If you look at an accountant who does 2 years of accounting for their masters, they then go into the workforce and expect to apply what they've learned. And of course, data scientists go into the workforce and want to apply these techniques. It just so happens that, these techniques might be useful for a lot of projects, but for a whole bunch of projects, they're not going to be useful. And maybe a more simple technique might get the job done in some cases. And so the question then is, well, how do we proceed in a robust way when solving problems with data? And at StoryIQ, we use what we call a 4A framework. And if you could follow this 4A framework, you're going to end up with a project that has a much lower probability of failure than if you hadn't used a robust framework like this. We call this the 4A framework. And the first A is asking the right question. And as we mentioned earlier, it's a question that drives business value and is feasible. But there's a number of other requirements that we want to place on this ask phase. I'm going to talk about those in a second. Once we've asked the right question, then we need to acquire the data. And this is easier said than done. You know, the data may be easily accessible internally, but more often than not, the data is in disparate places across the organization. Maybe some of it's in internal data warehouses, some of it's external. Maybe we have to purchase some of it. Maybe we have to do, run some tests or surveys or experiments to get more data. And then often the data is not in a great form, right? So we have to clean it up, deal with outliers, deal with bad data, missing data, wrong data, etc. Maybe the data is not in the right aggregations, and so we've got to, go through that process. After that, then we move to exploratory data analysis. We analyze the data, and many times we don't even proceed past point 2 and 3. I've had a bunch of projects where after we've asked the right question, we get to acquire, and then we realize, oh, hang on, we can't get the data that we need to ask this question. And so you've got to go back to the drawing board and come up with a new question. In other projects I've worked on, we've started with ask, we've gotten good data, we then proceed to analyze, and then we find out our data is not as insightful as we thought it was. Or if it's a machine learning project, our data is not as predictive of the thing we're trying to predict as we thought it was. And so again, it's right back to the ask phase. So ask, acquire, then analyze. This is where we're building our models, or if it's a more simple project, we're creating our graphs. And then point 4, once we've got our model, then we have to productionize that model and get the business to act on the results. In this talk, we're really focusing on the first A, ask. Because what you can see here is this is step 1. If you ask the wrong question, you go off wasting the company's resources acquiring data to answer this wrong question, or question that generates low amounts of value. And then we're analyzing and we're productionizing just something that was useless in the first place. So we really, really, really want to get this ask phase right. I talked about value and feasibility earlier. Let's break down, what does it mean to drive value in the business? If your data science problem is not, if you can't quantify how much of each of these or any of these it generates, then maybe your project isn't actually that valuable. So can you actually quantify how much revenue or profit is it generating for the business? Or how much cost is it reducing? Or how much efficiency is it driving? How much risk is it reducing? Or how much is it improving the customer experience, right? You want to be able to justify to the business what type of value your business, your data science problem generates. If it's not driving real value in any of the above, you may have fallen into the trap of chasing cool projects. Those projects are cool for showing off to your data science colleagues, not so cool for the shareholders of your business. So we've so far talked about asking the right question is the first phase of the data science project. We want it to be a feasible question to answer. We want it to generate value. And we've talked about the types of value we want to generate. Let's talk about good and bad questions a little bit more, because it's not just value, which is the question. We also want what I might call an answerable question. So I'll give you an example of a bad question, which actually is answerable, but it's actually not productionizable. Let's say we have a data scientist says, can we predict whether employees are more likely to take a sick day on work days that are next to public holiday weekends? So I'm not sure whether any of you have been ever tempted to do this, I know I have, when I used to work a 9 to 5 job. Let's say, okay, so there's a public holiday on a Friday, and then Saturday and Sunday is, of course, the weekend. So I may be tempted to take a sick day on a Monday, and that gives me a 4-day weekend. And so let's say we look at the data and we find that it does seem like on work days that are next to one of these 3-day weekends that are caused by a public holiday, we find that people are much more likely to call in sick or come up with some sort of excuse to not be at work on these days. And so the data science team says, we're going to build a model that predicts whether, someone is actually just faking being sick on this day. The model might say, there is a 72% chance that you are not actually sick on this day, or something like that. Now, this is a terrible idea, right? Even though we could build a model here, and we could get some data around this and come up with some reasonable predictions of the probability that someone's really sick or not. You can't put this into production. It's just a lawsuit waiting to happen, because eventually your model is going to have a false positive. It's going to say, this person is not sick, when actually they are. Eventually the model's going to be wrong. And so there's a lot of projects out there where the data science team could answer it using data, but you just can't put this into production, right? There's so many better problems that we could solve. It won't result in a potential Dole issue or lawsuit, right? So bad question there. Now, let's try to come up with a better question. How can I make my restaurant profitable, right? So let's say you've got a, Uncle Totoy, right? You've got Uncle Totoy, he's got a restaurant, and he says to you, how can I make my restaurant profitable? You're the data scientist, tell me how. Well, what I would tell Uncle Totoy here is that your question is too broad, because we can make a restaurant profitable by increasing revenue or reducing expenses. But then increasing revenue can be done in many ways. We could have more customers, or we could have the same amount of customers and increase the order size, right? So we need to actually break this problem down a little bit, right? And we can do this using something called a MECE issue tree. MECE stands for mutually exclusive, collectively exhaustive. MECE. And some of you have probably come across this before, but for those who haven't, this is a term that management consultants at companies like McKinsey and Bain and the Boston Consulting Group, the top management consulting firms in the world, MECE is a technique that they use for taking an overall big problem and breaking it down into small component parts, which can each be assessed for feasibility and the amount of value that they generate. So I take Uncle Totoy's question. He's saying my restaurant is not profitable. And I say, okay, Uncle Totoy, we can break that down into two things. If we want to solve your problem, we can increase revenue or we can reduce costs. Okay. Now, to increase revenue, we could increase the number of orders, okay, by having perhaps more customers, or we could increase our prices. And if we can increase our prices and yet somehow have the same number of orders, then we would increase revenue. Otherwise, there's things we could reduce on the right. We could reduce our rental costs. We could reduce salaries, a bit hard and maybe illegal to do that. So I'm not seeing how feasible that is. We could reduce our raw material expenses. Maybe we can buy from, cheaper suppliers, but again, not that feasible. And so we can break each of these down as well. To increase the number of orders, maybe we could shift to a mall, which gets more foot traffic. I say to Uncle Totoy, I say, well, where is your restaurant? And he says, it's in Ayala Triangle in Makati. I say, okay, yeah, kind of busy, but not as busy as a mall, maybe. Marketing, promotions, etc., right? So what you can see here is that we keep breaking down. I call this a broad motherhood statement question. It's a big statement. It's sort of like, a big question like, how do we have world peace? Well, okay, we can break that down. World peace breaks down to, well, we need peace in the Middle East. We need peace in Africa. We need peace, we can break it down by region. And then if we talk about peace in Africa, we can then break that down to even more specific regions, then down to, things making up those minor regions, right? So the idea is to get to a point where we have a question that is answerable. So taking this part over here, I could actually now use data to answer this. Would shifting to a mall give us more foot traffic? And it turns out that we can get a competitive rate on rent in Glorieta 5. And so I can now ask the question, will shifting Tortoise Restaurant from Ayala Triangle to Glorieta 5 increase foot traffic and net profit? Yes. Would it increase foot traffic? I could get an intern to sit outside Tortoise Restaurant in in Ayala Triangle and literally write down how many people pass by for a day, right? And then we could find the site at Glorieta 5 where we are, expecting to put our restaurant. And so we could literally collect that data. And then we can look at, well, how much is the rent in Ayala Triangle? How much is the rent going to be in Glorieta 5? We could create some metrics around how much of a link between foot traffic and sales do we think there is? And we can start to get towards an answer here. Whereas with the big motherhood statement question up here, we don't know where to start there. So I encourage you, next time you have a project, and this is not just for data science projects, consider writing out a MECE issue tree and then deciding which of these components to work on based on feasibility and value generation. Not what we just think is cool or what just comes to us as the first thing that enters our head. We want much more structured thinking around how we solve problems. And so because of this kind of problem that data science teams often have, that they focus on the cool projects, the projects where, they get to use neural nets and Keras and TensorFlow. What has arisen is that we have the business on the left here, the executive sponsor. This is the person who cares about value generation and profitability. And so what's arisen is this role in the middle called the Analytics Translator. And so I just want to kind of expand on each of these. So over on the right, we have the data science team. They know the techniques, they know the tools. Their problem focusing on data science and learning new tools, often ignoring the business need. Their communications can sometimes be too technical. And I don't want to put all data scientists under the bus here. I've worked with some amazing data science talent, excellent communication skills, all right? So I am generalizing here. There are exceptions. They often ignore business feedback. The business might say, we've got enough error. Our error is low enough, like move on to the next problem. Often they will ignore things like that. Often poor data storytelling. They often focus on presenting the math behind their models when perhaps their audience can't understand it, etc. Right? So we've talked about that. The business, this is your executive sponsor to the project. They're responsible for removing the blockers in the way of productionizing models, executing on data science projects to get, there might be data confidentiality issues. There may be stakeholders who don't want to give up their data. So the executive sponsor, their role is to remove these blockers. They care most about value. The problem is the business and the data science and analytics teams are often speaking two totally different languages. And so what has arisen is this need for someone in the middle that we call the Analytics Translator. This is someone who is responsible for keeping things on track in terms of this 4A's process and guiding things along, making sure the question's good in the first place, So the Analytics Translator understands the business context, make sure that ask phase is done right and that we're asking a question that drives business value. At a high level, they understand the data science tools and techniques, and they help select the right data initiatives for the business to pursue, and they can talk to both the business and the data science team. And so this is a hot role. If I'm going to kind of name the top 10 hottest new job titles out there, Analytics Translator is a really emerging role. So what does the Analytics Translator do? I've got this tweet here from Cameron Warren, a data scientist who really gets it. I'll just mention AUC over here. This is just a measure of accuracy for a model. If you haven't seen this before, it's just a measure of how accurate the model is. The higher, the better. And so Cameron says it's satisfying perfecting a predictive model and eking out or getting out that last 2% or 5% of accuracy. Unfortunately, the time it took you to go from an 80% accuracy to 85% probably took as much time as it took you to get to 80%. Your value as a data professional is predicated on the dollars and cents that your models, pipelines, or data products are saving or generating, and nothing more. A little bit depressing in a way, but he's got a point. If we're working for private companies, then the aim is to generate value or lower risk or increase efficiency. We have to be focused on that. And this is why it's really important to pull up your colleagues when they are sitting there, optimizing their model for weeks and weeks. They're really wasting a lot of resources. Sometimes you have to say, you know what? The business is happy with the amount of accuracy that we've got in this model. Let's put it into production and move on to the next problem. So just summing up here, what have we talked about? We've talked about when it comes to asking a great business question, focus on value, focus on feasibility. Don't focus on tools or techniques. We've talked about the different types of value. It can be profit or revenue, or we can be reducing cost or lowering risk or increasing efficiency or increasing the customer experience. There has to be some measurable way of generating value. And then we've talked about when we're asking the right business question, we want that question, just going back here, we want it to be meaty in the sense that we're not asking a big motherhood statement question. We're asking a question that narrowed down. It's narrowed down and it is answerable with data. Okay. So that's asking the right business question. There was a lot there in 30 minutes. As always, happy to answer questions. Feel free, if you didn't get your question answered, hit me up, facebook.com/isaac.reyes. That is my data scientist page where I rant on about many of the things just like I've ranted on about before. Thank you so much for having me, Alma, and the Trend Micro team for putting on this great event, Decode 2020. Thank you all so much.